Okay, guys, last video of the semester. This is our review video for Unit 6. And so next class, we're going to just review everything for Unit 6. And then the next time you will take your semester exam, which is really just only over mostly Unit 6. And then you are on break and you're done with semester 1 and halfway through 6th grade. Can you believe it? So this is just to help you kind of go back over everything. Please make sure you study and you do whatever you need to do to feel confident and prepared. So here are just all our topics. I tried to break it down by lessons. So if you were, not sure about something, you could go back to that specific video to help yourself. So we're going to start and kind of go in order through this video, but since there are separate videos for each thing, I'm going to try to make it short and sweet. So you're not sitting here for like 20 minutes reviewing the whole unit. But if you, are having trouble with the properties of expressions, then go back to video 6-2 and look at that and, go more in depth because a lot of the stuff in Unit 6 is preparing you. It's like baby steps into algebra. And so it is very new to a lot of you. And so some of you might need to do some extra preparation and studying just to make sure it sticks. So here is all your vocabulary, and because I love you a lot, I have made a Quizlet set for you, of course. So that is on Google Classroom. You can go use that to study. Please make sure that you know the vocabulary because lots of times on the test, if you don't know what the vocabulary means, sometimes that can mess you up on a question because the question is worded in a way that you're not sure what it's asking you because you didn't review the vocabulary. So just make sure you understand these words, use the Quizlet set to practice, and we'll do a little bit of practice in class too, but make sure you review it. So we're going to start at the beginning, basically expressions and equations. So expressions and equations are very similar. They are just combinations of numbers, variables, operations, but expressions have no equal sign. And so with an expression, you can represent it these three ways. You have verbal, where you're saying it with words. You have numeric, where it's with numbers. And then you have algebraic, where you have a variable somewhere in there. And so the biggest thing about expressions is that you can simplify expressions or evaluate expressions. Those two words are important to know what they're telling you. And that basically just means do as much as you can, but you can't actually solve it or find sometimes a very specific answer like you're used to doing. So sometimes, your expression simplification, it looks like x plus 2, and that's all you can do, but you've simplified it as much as you can. So we've talked about that, but that's something very new to you guys. So just know expressions, you just do as much as you can to simplify it down. Sometimes that gives you a number, sometimes it gives you just another expression that's smaller than the first one. So an equation is like a mathematical statement, and it does have an equal sign. So an equation basically has two expressions that are set equal to each other. And so the cool thing about equations is that because they're equal to each other, you have like some kind of equitability there. You know that you can actually solve it. You can figure out what a variable actually means in that equation. So we've learned how to solve one-step equations, which we'll look at in just a second, but make sure you know the difference between expressions and equations. Then we talked about exponents. We've been doing these on warm-ups like every day, but some of you still are a little bit unsure about the concept of an exponent. So an exponent basically is the small elevated number that's up here in the corner of the base. This is what we call the bigger number, and it indicates repeated multiplication. So if I have, this is exponential notation where it's written with an exponent. So if I have 5 to the third power is how I say that. This really means multiply 5 by itself 3 times. So it would be 5 times 5 times 5. This is what's called expanded notation because it's all written out. And so when you do this, you would have to do 5 times 5, that's 25, And then 25 times 5 is 125. When you actually get that answer, that's called standard notation. So these are three ways. They're all equal. They're equivalent expressions, but they're written in different forms. So exponential form has an exponent, of course. Expanded form or notation is written all out like this with multiplication signs in between. And then standard notation or form is just the answer of that. So prime factorization is where you are factoring a number. So you're writing what pairs multiply to give you that number, but you're factoring it down until you only have prime numbers. So remember, prime numbers are numbers that only have the factors of 1 and itself. So like 7 is a prime number because I cannot multiply anything to get 7 except 1 times 7. So with 24, if I wanted to do prime factorization, you can pick any two factor pairs. So let's say I picked 3 and 8. Okay, 3 times 8. If you picked 4 and 6, it would still work out by the end of it. It would still work. If you did 4 and 6, if you did 2 and 12, it would also still work. So that's the beauty of prime factorization. So then you look at this and you say, is 3 a prime number? Oh, yes, it is. So that's done. Cool. That's a prime factor, but 8 is not. So I have to keep going. So let's split 8 apart. 8 I can split into 2 and 4, right? So I look and see, is 2 a prime number? Yes, it's a prime factor. Awesome. Okay, what about 4? Nope, I need to keep factoring because this is not a prime number. I factor this down to 2 and 2, and now I have all prime factors. Awesome. So really, since factors means, oops, sorry, I kind of missed the mark on those two 2's, but whatever. Since factors mean multiplication, I have to write all these being multiplied together. So I'm going to use the dot as my multiplication symbol this time because it's faster. And then also because, x's, or the time sign kind of looks like a variable, so we want to be careful with that. So I would basically write 2 times 2 times 2 times 3. And so now that we learned about exponents, I can really write, this is an expanded form that really represents 2 to the third power, right? And then 3 is just by itself, so times 3. So this is really how I'd want to write the prime factorization of 24. Okay, so definitely if you have any of your old warm-ups and stuff, those would be really helpful to look at because they always have at least one prime factorization on there. So order of operations, biggest thing to remember here, these are your steps, right? And it's super important that you show your work and you make sure you're following the actual order because all of you pretty much can tell me, oh yeah, PEMDAS, order of operations, blah, blah, blah. But then some of you do not actually follow that order and you don't end up getting the answer correctly. So basically, you start with parentheses. If you have no parentheses, you skip to the next step, which is exponents. You go through the problem. The biggest thing that people do that sometimes is a mistake with order of operations is multiplying and dividing happen in the exact same step. So it doesn't have to always be multiplying first. You just start through the problem on the left and you read through it. Whatever you come to first is what you do, either multiplying or dividing. Same with adding and subtracting. So you'll see in this example, as I started, these little arrows are where I'm doing that on the adding subtracting step. If I start moving through the problem, I actually am going to subtract before I'm adding anything over here. So because that's what's first. So 9 minus 5 is 4. Then I start again. 4 plus 12 is next, 16. Then 16 plus 5 is 21. So just make sure that you're being really careful with those steps, that you're doing whatever you come to first rather than just multiplying first and then dividing, because it might not work that way depending on your problem. And then also just be super careful that your exponents you're evaluating correctly, because 3 to the second power, a lot of you are still putting 6. It is not 6, it's 9, because remember that means 3 times 3. So then the properties, these were brand new to all of you. And so this is definitely something you may need to review a little bit more by watching the specific video, because I can probably guarantee you your semester exam will ask you to identify like which property is being shown on certain equivalent expressions. So properties are basically just rules that work with different expressions when you're doing operations. So most of them apply to adding or multiplication, but you can go back and look at that specific video if you want more information, but these are all of them: identity, commutative, associative, inverse, and distributive property. I would definitely look at distributive property one more time because that one was one that I know a lot of you were kind of needed a little refresher on in class, so you might want to just look at 6.2 as that video like in itself to study. So here are the parts of an expression. Basically, we have just different vocabulary words for these. Remember, like anything that is separated by adding or subtracting symbols by operations are called terms. So 3x is a term in this expression and 5 is a term in this expression. Then, if I have a number that's being multiplied with a variable, that's called a coefficient. The variable is the letter that represents some unknown value. Operation, of course, is adding, subtracting, multiplying, dividing. And then a constant is a number without a variable because it will never change. So make sure you're familiar with that. Here's our example from the video about writing equations. So be familiar with if they give you a word problem. This is all about problem solving and kind of stretching your brain to take information and then translate it into some kind of mathematical like equation. So make sure you're able to take a situation and then figure out how to write the equation of that. Remember, all our equations right now are one-step equations. So it should be pretty straightforward, hopefully. But if you need to look back at that specific video, definitely do that if you need to. So now we're at solving equations. Basically, our main goal is isolate the variable. You want to get it by itself and figure out what its value is. So first thing, identify where the variable is in the equation. And then ask yourself, what is happening to it right now? Which operation is happening with that variable and some other number? And then the second step is to perform the inverse operation to whatever is happening originally so that you can solve it. And then the last thing you can do is to check your answer using substitution. So, for example, you also want to be able to model. So here's a little model of this equation. You have positive 6 plus x as our variable equals positive 13. So the first thing you'd want to do is identify the variable. Here it is, x. I'm adding it with positive 6, so my inverse operation of a positive 6 is a negative 6, or subtracting 6. Whatever I do to one side, I must do to the other side. So if you want to draw a line down the middle so you know that you're keeping it consistent across this, each little side of the equation, definitely do that. So 6 minus 6 is 0. That cancels out. And you have the variable left by itself, x, equals, and 13 minus 6 is 7. So basically, if you added 6 negatives over here, it would cancel all of these out over here. And if you added 6 negatives over here, cancel 1, 2, 3, 4, 5, 6, leaving you with positive 7 over here also. So that's how you can use the models to help you out. Okay, here's just one more example with multiplication. So if I look at my variable, here's x. It's being multiplied with 3. I know that because 3 is looking like a coefficient right now. It's just right next to x with nothing in between, so that's how we know it's multiplication. So the opposite of multiplication, the inverse of that is division. So I divide by 3 on this side. Whatever I do to one side, I do to the other side. So right now I'm using like a fraction form to represent my division. 3 divided by 3 is just 1x. It cancels out, so I'm left with x equals 4 because 12 divided by 3 is 4. So if you look at our model, we have 3 little x's, okay? And so I need to split 12 into 3 groups. So there's a group, there's an equal group, and there's an equal group. And if I look inside of each group, there is 4 inside of each one of those. So x equals 4 that way. Okay, last thing was just solutions. This was pulled from that video actually specifically. So once you solve equations, you can check them by using substitution, replace the value that you found as your solution in place of the variables. So I take the original equation, and instead of y minus 6, I'm putting 4 because I found that y equals 4. So I put 4 in place of the y, and I just see, is 4 minus 6 really equal to negative 2? Yes, it is. That's how I can check that this is a solution. And then I place the just a dot wherever my solution is on the number line, and that's how I can represent it that way. So I would place a dot on positive 4. So I know that this was a very fast little recap. So again, please feel free to go back, rewatch it if you need, or go into any of the old specific videos to help yourself if you need a little bit more. I need to give you guys the quizzes codes because I didn't have them yet when I'm making this video. So I'll place those on Google Classroom, don't worry. But there will be a Quizlet set on Google Classroom as well for all the vocabulary. I'll put some quizzes codes for you on Google Classroom, and then you will have a test review that I will put the key on Google Classroom. So in the past, sometimes we get a little bit confused as to the expectation on the test review. It is going to be a completion grade, so please use it. It's a tool for you to study. It's going to count as just a daily homework grade. It should be a very easy 100. However, I really want you guys to treat it like a test. Like, take it as if it's a test for you and go through, do the problems, and then use the key to check your answers. The ones you get correct, put a little check. That's pretty good if you're getting them right on the first try. If there's some that you did not get right, you need to go back and look at what you did and look at the key and try to figure out what you did wrong, and then try them again. Try them over and over again and see how well you're able to improve. If for some reason there's one you just really don't understand or you have a question, then bring them to me and ask me either during study hall or tutoring, so that way we can make sure that you're on the right track before you take your semester exam. I will have tutoring pretty much every morning of the week of semester exams. So please come if you need help, and just come to class with these notes and any questions you have, and we'll do some review activities before our exam. Thank you for watching, and happy studying. Good luck, and let's end strong. Semester 1 is almost done.